Hello, hello, Shagathon here. Welcome back to another Rust coding stream here on the 12th of October, 2022, where the local time is 17:35, and we're going to be continuing this roguelike tutorial in Rust, just showing where we are at. Last time we got combat and the UI implemented, so now we actually have that chat log there, which is a lot nicer than what we previously had, and that's about it. I mean, we can die now, we can fight things, we don't have any way to heal or anything yet. That's going to be something we want to do soon. And then I'm dead. And there's still a little bit of an issue with the thing spamming "you are dead," but I think that's intended behavior. I didn't look too much into it, but I think that is intended for now because the tutorial says we'll deal with dying and ending the game later. So that's going to be like a whole main menu system and all that, I think. So we'll get to that at some point. But for now, that was a little demo of how the game works. There's one other thing I want to call attention to, the damage system. So we did this last time, and actually, no, it's not in there. It's a component. It's used in the damage system. It's suffer damage. We use a vector for it, and we accumulate damage in the vector, right? So we have some amount of damage and we push that into the vector, and then when we use the vector, when we actually take damage, we sum it up. So I think it's in here, yeah, here it is. So we actually sum up the vector, and I was curious why we're using a vector. I still don't really have an answer for that because I replaced the vector with an I32, and every time, instead of pushing into a vector, I did plus equal and just added the number in there, and it worked perfectly fine. There were no borrowing issues or anything like that. So not entirely sure what the reasoning behind that is. Maybe it'll be more clear later, but I just wanted to call attention to that because I was talking about it last time. So now this is going to be a lengthy section, so I don't want to waste any more time before getting started. Also, I don't know if I'm going to do two or not. I kind of said I'd probably do items and inventory and range scrolls. We'll see how things are looking after I finish the items and inventory section. It's pretty lengthy, and also I only got about 4 hours of sleep last night, so might be better, if it ends up being 2.5 to 3 hours on this section alone. I think ranged is also fairly lengthy, so it might be better, depending on how long this takes, for me to just go ahead and do one section today. So we'll see what happens. So without further ado, let's go ahead and start working on items and inventory. So far, we have maps, monsters, and bashing things. No roguelike murder hobo experience would be complete without items to pick up along the way. This chapter will add some basic items to the game, along with user interface elements required to pick them up. Use them, and drop them. Thinking about composing items. A major difference between object-oriented and entity component systems is that rather than thinking about something as being located on an inheritance tree, you think about how it composes from components. Ideally, you already have some of the components ready to use. So what makes up an item? Well, thinking about it, an item can be said to have the following properties. It has a renderable, a way to draw it. If it's on the ground awaiting pickup, it has a position. If it's not on the ground, say in a backpack, it needs a way to indicate that it is stored. We'll start with in pack. It's an item, which implies that it can be picked up, so it'll need an item component of some sort. And if it can be used, it will need some way to indicate that it can be used and what to do with it. So consistently random. Computers are actually really bad at random numbers. Computers are inherently deterministic, so without getting into cryptographic stuff, when you ask for a random number, you're actually getting a really hard to predict next number in a sequence. We call it pseudo-random number generation. The sequence is controlled by a seed. With the same seed, you always get the same dice rolls. Since we have an ever-increasing number of things that use randomness, let's go ahead and make the RNG, random number generator, a resource. So in main, we'll insert a new random number generator. And then we can now access it whenever we need it, without having to pass one around. Since we're not creating a new one, we can start it with a seed. We'd use a seeded instead of new, or excuse me. Since we're not creating a new one, we can start it with a seed, we'd use seeded instead of new and provide a seed. We'll worry about that later. For now, it's just going to make our code cleaner. Yeah, so I guess we're just not going to do that, I mean, as it said, but just making sure I read that and took that in as intended. So gs.insert, this is a good spot. We'll just copy that. And instead of run state, it's going to be RLTK random number generator new. Just like that, nice and easy. Yeah, nothing more to say on that. We'll actually start using it in a moment. So, improve spawning. One monster per room, always in the middle, makes for rather boring play. We also need to support spawning items as well as monsters. To that end, we're going to make a new file called spawner.rs. And it looks like this is going to be a big old beefy boy, so we can spawn monsters. Basically, it looks like we're going to just extract out our old monster spawning code. A lot of that looks like it's going to be similar, because this is our create entity. And it looks interesting. It's a generic, so yeah, that'll be fun. We're going to make a function that actually does a random monster. That's our like goblins and orcs and whatever. That's our table basically, right? And then we're gonna make a thing that spawns the player. So yeah, so anything that can be spawned, I guess, is going to be in here. That's why yeah, that makes sense. But just breaking down what we're going to do before we do it a little bit so we know what's in store. I don't think we're actually spawning anything else yet, but then that's going to give us room for items and everything else. So let's make spawner.rs. And in here, that's a big beefy super, so I'm going to just copy that. It doesn't even show up without me scrolling to the side. And then I'm also going to copy the comment because I'm lazy. And let's get started. So we're going to spawn the player first. So it's a public function called player, and it takes the ECS world. It's mutable because we're going to be modifying the world, right, if we're adding something to it. Player X, I32, player Y, I32, and it returns an entity. And that's going to be useful because if you recall, we're actually adding the player as a resource, so we need to get that entity back. So that we can add it as a resource. So ECS, and then all we're literally going to do is .create entity, and it's with a position. Now I'm going to be a little bit lazier and find the player code here. Create entity with position and all that stuff right there, and then I'll just double check what needs to change. Player X, player Y on position with renderable at yellow black. That's all good. With the player component with the view shed, range of 8, and it's dirty. Player is the name. Yep. 30, 30, 2, and 5. Everything is identical. See, that was way less time consuming than typing it out. This is a refactor essentially. So I'm okay with a little copy paste when we're refactoring, but do not do that if you're writing new code, right? You never want to do that when you're writing new code because you want to make sure you learn what you're like in a tutorial setting or something, right? If you're working with something of your own, copy paste where necessary. But try not to copy other people's work, not just in terms of taking credit, but in terms of learning. Like even if you're doing a tutorial, try not to copy their work. Write it out yourself. It may be more time consuming, but it's going to be way better for your learning experience. So we're gonna let roll is an I32, and we get the random number generator and do a roll. So again, this is a weird way to do it. I'm gonna modify it after the fact. Let mute RNG equal ECS.write resource, and it's random number generator. And then it's going to be roll equal RNG.roll dice. And then it's going to be 1 and 2. So remember, it's simulating 1D2, right? Oh, it's not showing up because we're not using it in main yet. So let me pull this into main so we get our autocompletes and checks and everything working properly. Use spawner, or no, mod spawner. Use spawner star, because we'll actually be using it. Expected entity. Oh yeah, and I didn't actually return the player, so we should just be able to, yeah, we can get rid of that. And we're returning the player, and I put create twice because of my copy. So now we're good. Okay. Now down here, variable role is assigned but never used. Yeah, we'll fix that in a moment. So we're going to match on role. And in this case, we know there's only two options, so we'll just match on one. And it's orc, ECS, X, Y. We're going to have two functions here. And then it's going to be everything else, which there's only one other value. Goblin, ECS, X, Y. I'm a little bit not comfortable with making functions for these. The functions are pretty simple, but I'm a little bit not comfortable doing that because I don't like the idea of making a function for every single entity every single enemy type that we want in the game. Imagine if you wanted to add another one, adding code is not the best way to do it in my opinion. It would be better to put it in like a file somewhere where we can read it in, and we may end up doing that. So let's just, keep that in mind for now. So we'll make orc. Actually, can I get away with generating these? Can I generate and generate? So ECS, mute world, XI32, yeah, beautiful. Okay. And this is Goblin, so it's going to be Monster, ECS, XY, RLTK, 2, CP437. It's going to be a G. And then it's going to be Goblin. I got to scroll over a little bit. Yeah. So that's all there is to that. And we're going to do the same thing for orc, but it's going to be an O. And it's just going to be the word orc. Easy enough. So now that's happy. I'm going to put this first just to match their formatting. Because if I'm looking back at the code, if they're in the same order, I'm less likely to make a mistake and work on the wrong function. And now we're going to have it auto-generate this as well. Can I just drag all that down? Thank you. Thank you kindly. So let's make sure everything's labeled correctly. No, because it's a generic. So S2 string. So this is a generic type constraint. We'll talk about it in a moment. But we're going to take mutable reference to the world. We're going to take XI32, YI32. And this here we're going to call glyph. And it's... A U16 would work, I guess, under the hood. I guess that CP437 does resolve to a U16 somewhere. But we want to do RLTK font char type. Whoa. Okay, oh, there's some weird stuff going on that I'm not used to yet as well. And in this last one, they're calling it arg. We're going to change it a little bit. So instead of arg and then string, because it doesn't know, it wasn't smart enough to know that we want it to be generic. So we're going to call it name, and we're going to say S. So look, see that's actually auto formatting now, by the way. Normally I do Alt-Shift F to do format, but I decided last night to turn on auto formatting on save. And so I'll have to get used to it because it does jump around like that sometimes. I was writing code last night and I didn't have a lot of time to get used to that. So we're going to do ECS create entity, and it's going to be with a bunch of this stuff. And I'm actually going to go ahead and just copy the monster generation entity stuff from here. That's it right there. So we're going to just plop this in here, and we're not returning it, so that's all good. It's with position X and Y with a renderable with a glyph, a foreground, a background, with a view shed, a visible tiles new, range of 8 and dirty true, with monster, with name, and we format name to string, so we're going to get rid of the numbering here, which I'm fine with. So it's just going to be name to string. And get rid of that. There we go. Blocks tile. Combat stats 16, 16, 1, and 4. See, we'll be expanding that as well because I'm sure we're not going to want every monster to have the same combat stats. So I know there's going to be more work to be done here, so I'm not going to complain too much. Cycle detected when computing function signature of spawner monster. Where is this cycle? Not quite sure how. Oh, because I didn't do the return. It should be no return, right? Yeah, we're not returning anything. I was like, wait a minute, that's why it's weird, because we're not returning. Okay. So, as I mentioned, we're doing a generic here. And what this is a, I think it's called a type constraint. That's what I usually refer to them as, but there might be a different name for it. Yeah, type constraint. It's constraining based on what traits something implements. So what we're saying here is we have a generic type S, and S has to implement toString. So anything that implements toString can be used here. It could be a rectangle that implements toString. It could be a texture format. If you have some way to represent it as a string, you could bring that texture in here as long as it implements toString, because toString defines that interface, if you will. It defines that interface of some function will be defined. You will have that function implemented for that data type, so we know that we can use it the way we intend to here. And this is where it matters because we're doing name.toString. So if, again, I could replace it with a texture, you know, I could pass in whatever I want. And one thing to note here is it's a trait for converting a value to a string. It's automatically implemented for any type which implements the display trait. So as such, toString shouldn't be implemented directly. Display should be implemented instead, and you get the toString implementation for free. Into and from work the same. If you implement from, you automatically get into, or the same with try from and try into. So they caution you, like, don't implement into, implement from instead, and you get both. Alrighty, so there's a bunch of stuff going on there, and we're going to clean up main a little bit. So, I mean, I'm not going to switch over to the browser yet. The browser says, though, as you can see, we've taken the existing code in main and wrapped it up in functions in a different module. We don't have to do this, but it helps keep things tidy. And since we're going to be expanding our spawning, it's nice to keep things separated out. So then in main, let player entity is no longer all this stuff. It is spawner player, and it takes nmute gs.ecs, and then player x and player y stays the same. So that's all good. And then for the monster stuff, yeah, so I'm actually gonna, let's see, I'm gonna move this up a bit. Where's this for loop end? Here's the random number generator, okay. So right above here, we're gonna make the player. Yeah, so we can get rid of this old random number generator. And then we don't need I anymore, so we can get rid of the enumerate. We'll skip the first room, and we'll say for room in rooms.iter.skip1. And we get the center of the room, and then we kill all of this, and we just spawn random monster. And mute gs.ecs, x and y, and we're good to go. How about that? We'll insert the map. I don't know why we're waiting to insert the player entity. I'm kind of following their code a little bit, but they don't actually show where the player entity is inserted. I'm going to put it where we actually get the player entity so it's cleaner. And that's that. All right. So everything should basically work. I mean, we spawned. That's, part 1 is working, and we can still fight, and part 2 works. Enemies are there. We have a goblin. We'll see that an orc spawns as well. Yep, there's an orc. We win. Everything's good. Hold on. What is this? Yeah, someone is responding to my message I sent just before stream. I saw something on Twitter of, I don't like to go too far out of the topic of the coding streams. I like to keep it pretty bounded. But I will mention this for a moment because I'm really interested in AI, and AI art is obviously big right now, AI generated art. And I saw something on Twitter where there was an artist on stream drawing something, and somebody like snipped that drawing, put it into an AI art generator to get them like a more complete version, whatever that means, right? To get the AI art generator's take on it. And then they put it on Twitter before the artist ever actually finished the initial work. So it's kind of not great. I don't really mind so much people using the AI art generators to do cool stuff or whatever, but taking somebody's work that they're not even finished with, like snipping it from their stream and then putting it up on your Twitter before they ever get to get credit for their work is really not great, to say the least. All right, so we cargo run, everything works. We have exactly what we had before. So now we're going to spawn all the things. We're going to extend the function to spawn multiple monsters per room, with 0 being an option. First, we change the map constants, which we introduced in the previous chapter, to be public in order to use them in spawner.rs. So, okay, we'll do that. I'll read a couple of things here, and then we'll go do them all at once. So then we want to control how many things we spawn, monsters and items. We'd like more monsters than items to avoid too much of a Monty Hall dungeon. Also in spawner.rs, we'll add these constants. They can go anywhere next to the other constants makes sense. So max monsters and items. And then still in spawner.rs, we create a new function, spawn room, that uses these constants. And it's just going to fill a room with stuff. Okay. So that's interesting. Spawn room fills a room. Yeah. So we're not actually making the room here. I think it's clear. I think you need to be clear on the language where we're not spawning a room, we're spawning things in a room. We fill a room. So what we're going to do is we're going to obtain the random number generator and the map. We're going to roll dice for how many monsters it should spawn. It then keeps trying to add random positions that aren't already occupied until sufficient monsters have been created. Each monster is then spawned at the determined location. The borrow checker isn't at all happy with the idea that we mutably access random number generator and then pass the ECS itself along, so we introduce a scope to keep it happy, automatically dropping access to the RNG when we are done with it. Right, because the ECS, RNG is part of the ECS. That would be why. So that reminds me, there was something I wanted to clean up somewhere else. Cleanup is relative, I guess, whether you agree or not, but I don't feel like this bit here is very rusty. I used to do Rust code like this. I don't see any reason to do this, however. I don't see any reason to initialize it, or to declare it here and then initialize it in here. We can flow up the information out of this scope, and we can treat this whole thing as an assignment. So instead I could say let roll I32 equal, and then out here we could do this, and we can just say, we can get rid of that and that, and now we'll do the work we need to in here. This will still keep the borrow checker happy because of the scope, but we're going to get the random number generator, roll it, and just spit that number back out of the scope into this variable roll here. It's cleaner in my opinion. It's more rusty, I would say. And I don't mean to nitpick too much, but I think it's probably safe to say I've written more Rust than this author had at the time of writing this. I might be wrong, but they said that they did this originally as like kind of an excuse to learn Rust. That felt kind of C-like. And again, there's nothing wrong. I like C, but Just want to call out ways that I think are probably a little more common in Rust. I think you'd probably see this. Although both are equally valid. Okay, so we're going to go ahead and do all that extension stuff that we talked about. So I need to find the map. And we have these three constants here. They all become public. And then we'll add more monsters. So in spawner RS, we'll add a couple. So where's spawner? And we'll say const max monsters I32 equal 4. Const max items I32 is 2. And of course we're not using it, so it's mad, but we'll use it in a moment. So we're going to make this spawn room function. So we're going to fill a room with stuff. Public function spawn room, ECS, and mute world room and rect. Let mute monster spawn points vac usize equal vac new. So points we mean like actual locations, I assume. We can't find rect, so we're gonna have to pull that in from super if we can. And although if we were actually using points, I would think we would actually use points as in the point type that we already have used. So we'll see what's up with that. So scope to keep the borrow checker happy. And we're gonna say let mute RNG equal ECS.write resource. And it's random number generator. So we get write access to that resource, and that's actually necessary. I'll explain why. So first we're going to roll dice. I'll explain a little bit about how random number generation works here in just a moment. Oops. Actually, you know what's cool is let's put max monster and cargo build. Usually it's smart enough to say, yep. So let me scroll this, expand this real quick. So const max monsters, similarly named constant max monsters defined here. So it's smart enough to say, hey, you might have just made a typo. There's something really similar, but I don't know that you meant that. So I still have to tell you it's an error, but really cool, really nice of the Rust compiler. Very, very, very helpful. I'm curious why we're doing this the way we're doing it. Max monsters +2, -3. So if the max monster is 1, then we get 3 minus 3 is 0. If the max monsters is 2, then it's 4 minus 3 is 1. So we roll 0 or 1. I'm not entirely sure about this. Let me think. So again, if the max monster is 1, and we say 1 plus 2 is 3. So if we roll a 3, we just minus 3 and we don't get a monster. That's weird. Am I missing something? Whatever for now. So we're going to loop through all of the monsters, basically. And let mute added equal false, while not added. Let x equal room.x1 plus rng.roll dice 1. And it's going to be I32 abs room.x2 minus room.x1 as usize. We're going to do the same thing for y and just modify a couple of values, so we'll copy that to make it quick. And there's going to be room.y1, and it's going to be y2 minus y1. So that's easy enough. The idea here is, I assume, fairly straightforward. We're trying to find out the total width and height of the place, which is why we're using the absolute value and getting the difference between the two. Let index equal y times map width plus x. And then if not monster spawn points dot contains an index. Okay, so that's why we made them usizes. So we're not using the point type because we're indexing into the map. So since we have a 1D array that we're treating as a 2D, we can get away with that type of indexing and call that a point. So monster spawn points dot push idx. And in this case, we're actually not really doing full-on indexing. We're calculating the index, but we're not actually doing anything. We're not like actually indexing into anything. We say added equal true. So we loop through until it actually does something valid. And then there's a lot of closing here. This is the end of the scope. Actually spawn the monsters. For index in monster spawn points dot iter. And we're going to use each one of these indexes. So let x equal star idx mod map width. Let y equal star idx divided by map width. Again, I suggest drawing out a picture and actually, do it on like a 5x5 or something and actually see how this works. But basically the mod is wrapping us back around if we go too far on our width. And then for the height, it's just basically getting us that remainder. Or it's kind of the other way around, but because mod technically is getting you the remainder, but in this case it's functioning like wrapping us around, and then what we get with the division is where we're actually at in the row, or in the in the row, like which column we're in. So random monster ECS X as I32 and Y as I32. I'm still a little bit curious about the number of monsters. So let me just read that one more time. It's 1 dice and it rolls. So max monsters is 4. Okay, so again though, I'm curious about like all values for max monsters, but our max monsters is 4. So then we add 2 to it. So it gives us 6, and then this gives us 3? Why are we doing that? So this actually... Yeah, I'm a little bit confused by that. Definitely a little bit confused by that. I think it's a cheeky way, actually, to utilize 0. Because we're looping through... Okay, yeah, I think it's a cheeky way to utilize the 0 here. But is that the only way to do it? I feel like that's very obtuse to look at. So let's plug another number in, and let's say 10. So 10 plus 2. So what 10 is would be 0 to 9 if we start at 0, right? It'd be 0 to 9 are the valid numbers. So that gives us 10 plus 2 gives us 12. And then we subtract 3 from it, we get 9. And that should work with anything. 20 plus 2 gives us 22, minus 1 is 19. So why that way? Not 100% sure on that. Oh, no, I get it. Maybe. But couldn't you just subtract 1 from it? Couldn't you say roll a d6, and that gives us values from 1 through 6, and then just subtract 1 from that to index it from 0. If you roll a 6, you now get a 5. If you roll a 1, you now get a 0, and anything in between. That's weird. But then, yeah, we are going from 0 to num monsters. So, you know, even if you put 1 monster plus 2 gives us 3 minus 3, then the only value we can get is 0. I have a smart package. Cool. Not 100% sold on that method because I feel like it's obtuse and you'd still get the same result otherwise. But hey, we're going to accept it for now. So I've already read the next little section there. So then I'll recap it once we get back. But in main RS, we're going to replace our monster spawner. There's a loop somewhere in here. Here it is. So instead of random monster, we're also going to get rid of that. And we're going to do spawn room with and mute gs.ecs, and then it's going to be room. And we can actually leave the semicolon out, but it doesn't really change anything. In this case, you could get away with that in Rust. So we can do the cargo run in a moment, but I want to take a look at something over here. I did call attention to this earlier, that random number generator is a write resource, and it's going to be it's mutably borrowed, and we're not being warned that it doesn't need to be mutable. So it must be mutated somewhere, right? And I'm going to bet that it's happening when we actually roll the dice. So I want to explain a little bit about random number generation. We didn't go much into it, but we see roll dice takes a mutable reference to self. So something that was mentioned earlier in the tutorial was that random number generators are not like really random, they're seeded, and the proper name for them is pseudo-random number generator. And the thing is, if you pass a seed in, you always get the same result. That's the pseudo part of it. But there are mathematical ways to prove that a random number generator has enough entropy to be indistinguishable from true random, assuming you don't know the seed. So, and that's important if you're into cryptography or whatever. You need to be able to prove that your random number generator is random enough, basically, that it has enough entropy. But the way that this generally works is there is some internal state to the random number generator. It's a struct somewhere and it has some value inside of it, which is the seed value, and you perform some weird operations on that seed value, and it has some other data that's being manipulated and modified. So every time you say, give me a new number, that internal state mutates more and more in a way that's indistinguishable from true random. Again, assuming it is an actual like good cryptographically secure random number algorithm. Now, if you're running something like a game, especially a more simple game, you probably don't need cryptographically secure random number generation, but that is something to watch out for if you're ever doing any application that needs security or whatever. You want to make sure you're using a good random number generation library. But the other point I was getting at is the mutability is that internal state, right? The way that the random numbers are generated is you use that seed to set up the value, and then with like whatever initial things happen when you seed it, there's that internal state, and every single time you call you say give me a new random number, that you're running some operations and modifying values, and then ultimately it spits out a number. I've actually implemented some of these before. You can look up some algorithms even on like Wikipedia, and they're fairly trivial to implement. They're actually not hard to implement some pretty good random number algorithms. It's a fun exercise. Like if you know how to program, like if you're following along with everything here, you could do that easily in an afternoon. In an hour or two, like you could implement multiple algorithms, because just getting them implemented is not that difficult. Making them into a nice library or something is another question. So the other thing is about seeds. I don't know how our random number generator is working here with new. Does it get a random seed? Yeah, so it creates a new RNG from a randomly generated seed. Now that seems a little bit odd. we can go here and see how it works. And they're using XOR shift. That's actually one that I implemented. I was going to mention that. Let's see. So new random number generator, seedable RNG from entropy. So you can get, so before I even look at what from entropy is, there's a couple things you can do. One of them is you can get the system time. System time, especially if it is of enough fine grain, meaning if you're getting it at microseconds or something, or picoseconds, if you're able to go to that level of detail, it's probably good enough to be sufficiently different every time. Maybe. You might find some interesting anomalies if not enough bits are changing every time that you sample the time to use as your seed. So there are potential issues there. If you're trying to seed like 10 random number generators, you know, all back to back to back to back to back, and there's not enough time changing between those, you might not get a lot of entropy. But that's, you know, far beyond the scope of this. So that's one way to do it. Another way is you can sample things like hardware information as well. So you could take the mouse location on screen, right? You can take various information from the hardware, like the different components. You could get things like system data. When I mean system data, you could pull the operating system for things like CPU usage, various things like that that are all random, basically, that aren't easy to replicate, right? So from entropy could be sampling any number of things, and we'll see what this actually tells us. So creates a new instance of the RNG seeded via get random, and this method is recommended way to construct non-deterministic pseudo, this is PRNG, pseudo random number generator, since it's convenient and secure. In case the overhead of using get random to seed many PRNGs is an issue, one may prefer to seed from a local PRNG. So we can then take a look at get random as well. Come on. Oh, this actually took me to, oh, there's a get random crate. Okay, it took me to my browser, but not the browser you can see. I'm just determining if I want to spend time and show this or not. I don't think so, but it goes to the operating system's random number generator. So on Linux and Android, it uses get random. On Windows, it uses bcryptgen random. On Mac, it uses get entropy. If available, otherwise dev random. So, I mean, there's different ones depending on your operating system. There's like 20 OSs listed here. I'm not going to go over it, but just thought it was worth going down that rabbit hole a little bit and also explaining why we did that scope trick to make it happy here, because we actually are mutating RNG, and we have to remember that the RNG comes out of ECS. So by taking the RNG random number generator out of the ECS and then passing the ECS into random monster here, it's not happy, right? So it's like, wait a minute, you took a mutable borrow from ECS, now you're trying to give ECS to somebody else. We can't do that, right? And this is Rust. So there we go. That was a big old long aside, but I think it was worth it and hopefully interesting. It's been a while since I've taken a cryptography course. It's super, super, super math heavy, but it's also really fun. Like the implementation and everything. I don't care as much about the math, but the implementation, the algorithms and all that, it's a lot of fun. RNG, not Xorg, when I type Xorg, XOR shift, and we could take a look here at some of these algorithms, and they're fairly straightforward. So the XOR shift algorithm is entirely on the screen here in C code. That's it. XOR shift plus, XOShiro, we have 256, 256 plus. I think we had a 512 somewhere. But I mean, these are really simple. Like, again, very, very trivial to implement. You can take this code here and go do it in Rust in just a few minutes if you're just copying this. Not super difficult. Worthy to look into if it's interesting to you. And this one here is a C version of 3 XOR shift algorithms. So yeah, we have an XOR shift 32 state. And what we see here, by the way, is that The state is just a uint32, so a U32 in Rust, or a U64 here in Rust, and then we perform some bitwise operations on it, right? So we do an XOR equal to this same value shifted over by 13 bits. Do it again, shifted the other way by 7, shift the other way by 17. And then we set that value as our new state. So that's where the mutation is happening under the hood. All right, though, I'm getting way too off on a tangent. Trying not to, but it's interesting. So yeah, if we cargo run the project now, we'll have between 0 and 4 monsters per room. It can get a little hairy. I don't know if I like that. Let's go ahead. Oops. Well, build is fine, but I want to run it. I don't think we ran it with the new generation. Oh yeah, that's more than one, all right. Can I win? Yes, I did, but... Oh, this is a cool map, though. The way the two rooms intersected right on the wall like that made a nice, big, open, like, interesting-looking room. I'm dead. Oh well. Alrighty, let's get back to the tutorial. Health potion entities. We'll improve the chances of surviving for a bit by adding health potions to the game. We'll start off by adding some components to help define a potion. So in components.rs, we're going to add item and potion. And then we, of course, need to register these in main.rs. So we'll do that. And then in spawner, we'll add a function called health potion. So let's go ahead and get to all that. You notice I just got lazy and copied this bit right here. All right, 1 second. Okay. Pub struct item and pub struct potion heal amount I32. I was gonna say I don't know how I feel about potion, but it kind of makes sense. But we might have other potion effects, so we might even abstract away the heal amount and make it some kind of an effect enum that can have behavior baked into it. I don't know the best way you would do it in an ECS, but that's the first thing that comes to my mind. Because I like the idea of like a defensive potion that gives you like resistances or something, or what if it's your magic or fatigue or like any kind of thing that's not health, right? Okay, so then we're gonna register them. So item and potion, there they are. Item and potion, cool. All right, and then in spawner, we're gonna go ahead and add the thing. Hold on, what's going on, Omnivore? You are dead. It is. It's very artistic. Yeah, like I said, that'll probably be fixed later. That's my assumption for now. So anyway, let's add the thing. So health, potion, takes the ECS, I32Y, I32. And we're gonna just create entity with a position. X and Y. With a renderable, I really don't feel like typing that out. So we're gonna copy that old renderable. Although I could have probably already done it. That's my favorite kind of laziness. And we're gonna actually have to give it a glyph though. My favorite kind of laziness is where you spend more time doing something the lazy way than it would have taken to do it otherwise. We give it the item component and the potion component. And build it. All right, yeah, I missed something. Oh, it's because we're not pulling in item and potion. And then we're going to do that as well. So let's grab item and potion. And that's all happy. So as the tutorial gods say, this is pretty straightforward. We create an entity with a position, a renderable. We pick the exclamation mark because it looks a bit like a potion. And, oh no, that's an eye. Oops. Let me fix that. Yeah, I was like, I guess. Oh no, I did put an eye. It just looks different. The fonts look different. Okay, I did it correct. So we use that because it looks a bit like a potion, and my favorite game, Dwarf Fortress, uses it. A name, an item component, and a potion component that specifies it heals 8 points of damage. Now we can modify the spawner code to also have a chance to spawn between 0 and 2 items. So in spawn room, we're going to add all that good stuff there. Omnivore was saying, you are dead, you are dead, you are dead. Truly, a rogue is birthed through death. Yes, indeed. I mean, yeah, it's a roguelike, I guess, right? Sometimes it be that way. So we're going to get the number of items up here as well. We're going to do this funky way of doing it, which I still don't see the full use for. I'm either doing the math wrong in my head, or you could just subtract 1 from everything and it would also be valid. The +2 -3 just feels weird to me. I don't want to get stuck down that rabbit hole again, but if you're rolling a d6, you get values of 1 through 6. If you just take 1 away from that, you get 0 to 5. I don't, why? Like, I understand why they want to start at 0, so we can loop, you know, from 0 like a normal loop, but still, something weird there. All right, we're gonna go ahead and do this for the number of items though, for I in 0 to num items, and it's gonna be let mute added. You know, it's gonna be like the same thing. Let's take this and modify a little bit. All that's the same, and then if item spawn points, yeah, I didn't add that, so let's add item spawn points. If item spawn points does not contain that index, then we push in there. I think everything else is identical. Let me double check, make sure I didn't mess up by copy pasting. So added is false, while not added. We get the X and Y, get the, convert that to an index. And then if the item spawn points does not contain it, push it in there. And we change added to true, so we stop looping. All that's good. So we actually spawn the monsters, and then we actually spawn the potions. So we'll say for index in item spawn points dot iter, and we'll do let x equal index map width, let y equal star index divided by map width, and health potion is the function. ECS x as I32 and y as I32, and that's all we got to do here. Also, I forgot to semicolon these because it doesn't matter, but we'll do it. We'll do it to be correct. Alrighty, so now if we cargo run the project, rooms will sometimes have health potions. Tooltips and rendering just work because they have the components required to use them. That's pretty sexy though, I like that. Let's find us a potion. Go away, goblin. Get out of here. Oh, rude self. I'm trying to find potions, okay. And there we go, we have a health potion. Yeah, just works. Also, having a chat issue here, both on OBS and my phone. Connecting to chat, how odd. Hopefully it works out, hopefully there's no issue going on. Maybe sometimes things happen, right? But hopefully there's no issue going on. I'll give it a moment and then we'll see what happens. So yeah, they work because I already have the components. That's pretty cool. Let's recap. Was there anything else I wanted to recap? No, I don't think so. Okay. And then that's what I just read. Tooltips and rendering just work because I have the components required. So there we have it. So now we're going to pick up items. Chat is still not connected. Well, I'm sorry if you're trying to say anything. I don't know if it's happening on your end as well, but I'll just keep my eye out and maybe it'll fix itself. Picking up items. Having potions exist is a great start, but it would be helpful to be able to pick them up. We'll create a new component in components.rs to represent an item being in someone's backpack. We'll call it in backpack. We also want to make item collection generic, that is, any entity can pick up an item. It would be pretty straightforward to make it work for the player, but later on we might decide that monsters can pick up loot, introducing a whole new tactical element, bait. So we'll also make a component indicating intent. Oh, okay. Wants to pick up item. That's kind of clever. I like that. And then we'll put together a system to process wants to pick up item notices. We'll make a new file, inventory system.rs, and we'll build that system. So let's go ahead and start plopping all this into our code base here. So first of all, we want the components. For these, we need clone on one of these as well. We need clone on both. So clone. And then what is this first one? Pub struct in backpack. Pub owner entity. See, I like that a lot. Pub struct wants. Ooh, what was that? Wants to, but instead of melee, pick up item. Pub collected by entity. Pub item entity. All right, so yeah, that's cool. It's just a way to kind of track that something is happening because it's going to happen over multiple turns if they have to walk towards it or something, and that's going to affect their AI and everything, I guess. Okay. Maybe. Because even the player wants to pick up an item, and then we'll have to check to see if they can, I guess. So now we got to do the system. So we're going to do this in inventory system.rs. Still... Oh, reconnecting. Oh, no, no, it's still broken. Let's check OBS real quick. OBS has a spinny boy saying connecting to chat. My phone, I think, switched over to just saying reconnecting with no spinny boy. Okay, inventory system here. We've got a bunch of used stuff that I'm too lazy to copy or to type out. So we'll just let that do its thing. And pub struct item collection system. And now what we're going to do is we're going to go to main and we're going to use the inventory system. We're going to bring it in as a module. Also, I guess, I don't need to do that, do I? Because both of those are still complaining and I'm tired of it. So yeah, we have inventory system now, and that'll get us the proper, see, we're already getting warnings that nothing's being used. That's okay. Impl. So we do need the lifetimes here for item collection system. So we're going to impl system for this. And Flippy's going to complain about type complexity, so allow Clippy type complexity type system data equal And it's a big old beefy boy. Read expect. And what are we? That means it's a resource. Remember that. The expect ones are resources. Write expect. Game log. That makes sense. Write storage. Wants to pick up item. Write storage position. Read storage name. And write storage in backpack. A lot of things here. A lot of things going on here. It's going to suck breaking this apart to implement missing members. So we'll get our run function here. And mute self. Good. Data, self-system data. All good. Is there an easy way to destructure all this? Data dot let. No. I'm wondering if there's like a quick way to destructure a tuple. No. Yeah, there might be something, but the naming would be a problem. Yeah, I mean, you could auto-generate names based on the types. But, whatever. Player, entity, mute, game log, mute once, pickup, mute positions, mute backpack. Oh, no, that's not right. Names, and then mute backpack. Equal data. Yeah, it'd be cool to just do like data and then have it auto destructure into something, and then I could just go in and manually change a couple quick things. That would be nice. Instead of having to do all that. Okay. So for pickup in once pickup dot join, we've never done that on a single thing like this before. I find that interesting. Positions dot remove pickup dot item. Oh, that's mad up there because I missed. How did I not notice that? Tunnel visioning in. Backpack dot insert pickup dot item in backpack. Pickup dot collected by dot expect. And what are we gonna say? Unable to insert backpack entry. Okay, what's next? If pickup dot collected by equals the player entity, game log dot entries dot push format, you pick up the blank, names dot get pickup dot item, and we got to do we're doing an unwrap. Not sure how I feel about the unwrap. And let's see. Just a moment. All right. Yeah, it was looking funky because it was trying to return that out of the if. Okay. So we finished the if, we finished that, and then the last thing we do here is once pickup.clear. So what I'm noticing is what we're actually doing here is this does not necessarily indicate just intent to pick something up in the future. It is being used more immediately, like the damage system, like once melee, it's used more immediately. So it'll be interesting to see how the AI on the monsters would have them picking something up. But basically, we're not trying to see if they're close enough to the item. We're assuming they are. Because the very first thing we do is remove the item from positions and just put it in the backpack. No checks, right? I am still a little bit concerned about this this unwrap. And I guess I'm a little concerned that we just assume that it has that name. We didn't do the joins, right? But I guess you can't really do join, because if we did a join, what we're doing is we're crossing between different entities, right? Because the item is an entity and collected by is an entity. So we have different entities doing this work. So yeah, we can't just join everything, because then this wouldn't make any sense. The item is not the same entity as the one that wants to pick it up. Okay, yeah, that'll make sense then. Hopefully it does to you. So what this does is it iterates the requests to pick up an item, removes their position component, and adds an in-backpack component assigned to the collector. Oh, it looks like... Okay, let me reopen my phone. Stream Manager. Okay, I'm in the chat, and it looks like... Yeah, it's working now on OBS and my phone. Had to reset it on my phone, but OBS fixed itself. Alrighty. So it iterates the request to pick up an item, removes their position component, adds in backpack component assigned to the collector. Don't forget to add it to the system list in main. And yeah, I don't really think there's much else to say on that. Again, literally just every request to pick something up, just pick it up, right? Theirs looks a lot more concise because they're stretching out the lines. The auto formatter's making longer lines for sure, or spreading things out more, but I think it's cleaner with the formatting. So let's go ahead and add the system. Let's see, system. I don't think there's really a special place to put it. Let mute pickup equal item collection system pickup dot run now and mute self dot ecs. There we go. Okay. So the next step is to add an input command to pick up an item. G is a popular key for this, so we'll go with that. We can always change it. In player.rs, in the ever-growing match statement of inputs, we add another virtual key code. I don't have player open yet today. So where are the matches? We're going to be a little lazy. And we're going to say G. We're going to delete these other things. And then instead of try move player, we're going to have to add this get item component or function. Get item. It's going to take it's going to take the ECS. It's mutable. Yeah. So it's and mute, not star, and mute gs.ecs. And that's it. Yeah. Oh, they actually showed that. I was figuring it out. They actually showed it, which is nice. I feel like I'm missing something, because see here, we're not putting commas after every arm of the match. And sometimes I have brackets like this. I have the curlies. But sometimes I get complaints that you need commas. I'm like, but I don't. Like, I don't have it. Maybe it's a Rust version thing. Maybe the version I'm using on my work machine is older and doesn't. I don't know. Whatever. Let's generate that. It's going to be here, right? Yeah. So ECS and mute world. We're going to get let player position. So ECS.fetch point. So the only like the weird, I don't know if tricky is the word, but the weird thing for me is like recognizing the difference between fetch and like the read storage and write storage and all that. It's not necessarily difficult, but it's the difference between a system and a regular function that's not a system, right? With the system, you're defining things that get pulled in automatically. With a regular function like this, you have to pull those things in yourself. That's the difference. So it's nice with the system that we know we just get some of these things for free, so to speak, as part of that system. But this almost feels like you have a little more control because you're manually like grabbing what you want. So we just get all the entities, let items equal ECS.read storage. But to be fair, the system does feel a lot cleaner in some ways. All right, so we get items, we get positions, and game log. So this is fetch mute. I probably could have done that faster without all the extra, without all the copy paste. Item positions and game log, huh? So that's everything we need. And let mute target item option entity equal none for item entity item position. Okay, so we're gonna join up entities. I'm just trying to guess entities, items, and positions. Yeah. I also think I forgot to do something. No, I don't think I did. We'll double check though. Components wants to pick up an in backpack. Ah, I did. There we go. Don't forget to do that. I don't know why I just thought about it, but glad I did. Okay, back to this. That was a random distraction. Oh no, it's in player. Okay, so we get all that fun stuff, and see if I save, it formats, and that I have a habit of just saving all the time, so I got to get a slightly different workflow now. So what we're gonna do, we're gonna loop through if position.x equal player dot position. Hold on. Oh, player position dot x and position y equal player position dot y. Target item equal sum item entity. So this is we're not breaking or anything. Can't you return from a for loop? You could return from a loop. This will return from the function, but you could return from loops. Like you can name your loop and then return from the loop with a value if you're doing a regular loop, not a for loop. But what happens if let t equal no, I don't know how to feed something out. I don't know if you can. Oh no, it's break. No, yeah, okay, yeah, that's how you do it. You don't use return. Break with a value from for loop. You can't do that. You can only break with the value inside a loop or breakable block. So the for loop, I don't think actually gives us any value. Okay. So match target item. I do wonder though if it would be better to just break once we find that. Because if there's like more than one item. No, because it's a target item. No, yeah, I don't agree with it because if there's more than one position or more than one item at that position, it's just going to keep overriding it. It's going to pick up the last one it finds. Unless I'm missing something. Gamelog.entries.push. There is nothing here to pick up. To string. Otherwise, we have some item, which is an entity, yeah. Let mute pick up. ECS.write storage. Wants to pick up item. Oh, I need it's a full turbo fish. I forgot that part of it. Pickup.insert. Player entity wants to pick up item collected by player entity and item. It's probably star item. No, item's good. But then we got to do an expect on the insert. Unable to insert, want to pick up. Alrighty, and there we have it. So this obtains a bunch of references slash accessors from the ECS and iterates all items with a position. If it matches the player's position, target item is set. Then if target item is none, we tell the player that there is nothing to pick up. If it isn't, it adds a pickup request for the system we just added to use. If you cargo run the project now, you can press G anywhere to be told there's nothing to get. If you're standing on a potion, it will vanish when you press G. It's in our backpack, but we haven't any way to know that other than the log entry. So let's run it and find out. And I was just thinking, you wouldn't probably want to pick up all items at once. Oh, I made something mad. What did I do? Oh, position. Oh, because we already had it. My bad. There we are. Okay, who's mad now? Someone is mad down here. That's why position wasn't resolving earlier. I noticed the X's and Y's were just white, and I just kind of went with it. Okay. Let's find us a potion if we can. These rooms are empty. There's nothing going on in here, man. Yo, what is this empty ass dungeon? This is the emptiest one I've seen yet. There's a potion. Oh, the potion's being drawn over the player. Very interesting. I don't know if we've done anything to address that yet. I think we will soon. Actually, we may do it next, because it may say, but you may notice. So we now picked up the health potion. Yeah, we need to make sure the player is drawn last. Basically. I kind of felt like we did something with that, but maybe not. let's take a look real quick. It's in the where do we draw? Not GUI. Where visibility? No, that's not what it is. Oh, right, that's the FOV stuff. So components, game log, GUI, main. Draw map. Let's go to main. Could be one of the last things we do. Oh, it's yeah. It's just in here. Everything with a position and renderable. What we want to basically do is maybe add an extra thing to say draw the player, or we could could we exclude the player from this and then have a separate call? I mean, we could. I was wondering if you could do the join without the player. Dot. What else can we? Okay, well, we'll look into it. I think we may deal with it, so I'll let the tutorial do it, but I'm thinking about it. So this obtains a bunch of references from the ECS, iterates all items with a position. Yeah, if you cart a run, you can do that. It's in our backpack, but we haven't any way to know. So now we're going to list inventory. It's a good way, or it's a good idea to be able to see your inventory list. This will be a game mode, that is, another state in which the game loop can find itself. So to start, we'll extend run mode to include it. So waiting input, pre-run, player turn, must return, turn, show inventory. And then the I key is popular for inventory. B is also popular. So in player.rs, we'll add the following to the player input code. So we're going to have a virtual key code for I. And in our tick function, we'll add another match for show inventory. And this naturally leads to implementing show inventory in GUI. So that's a lot. Let's go ahead and start doing that one at a time. The compiler is going to help us a little bit. So first of all, our game state in main is going to break things. We're going to get some red immediately because it's a non-exhaustive match here. So that's fine, but we'll deal with that as you know, we do. So in here for our input, we're going to say virtual key code I. And instead of get item, it's going to be show inventory. Oh no, it's going to be game state. No, we're not actually calling a function here. We're calling it elsewhere. So run state show inventory. Also, did we return a state earlier when we call get item? Let me double check. Where is get item? No, get item's not returning any state. So it just says player turn, right? It falls back onto player turn. Okay, that's what it is. Why are we mad? Hold on. I got sidetracked in the middle of that, so now I'm wondering what I'm missing. Return. Oh, we're returning it. Yeah, there we go. Okay, that all works. So now main is like the only place that's mad. So what we do is we come here and we now have a nice new branch to show inventory. And it's going to be if GUI show inventory self CTX equal GUI item menu result cancel new run state. Oh, we're not going to do new run state equal. We're going to do it my way. run state awaiting input. If they canceled, we're awaiting input. That's basically it. Oh, what's going on? Oh, I love that comment. Thanks for the follow. I appreciate that, Chumley. This is Print. Hi, Shoggoth. Great programming. I love it. Thank you. Appreciate that. And thank you for the follow. Okay, so there's a little bit of oddity here because I'm doing this a little bit differently. So we would need an else here. And the else would probably be, I assume that we've taken a turn. So run state player turn. How you doing today, by the way? Hope you're doing all right. I do like that. It's a nice first comment, first chat message. So we're going to generate that function automatically, so I don't have to do it. And it should get pretty much everything we care about. I'm going to rename a couple of things here. So first, instead of arg, it's going to be game state, and I'm going to modify this a little bit. Oh, we got with the Prime sub. Thank you so much. I appreciate that. It's coming in hot. I really appreciate it. Yeah. I'm finally getting chat messages again too. Oh wait, a double Prime sub. Wait a minute. I missed one of those. Hold up. Wait, that wasn't a follow. Ooh, my bad. That was a... Wow, okay. Hey, thank you, Stony B. I didn't realize... I misread that at first and thought it was a follow because I have, like, the stream manager on my phone is, like, so tiny. And I just heard the sound. No, thank you so much for that. We got a double Prime follow coming in. Yeah, happens to the best of us. Keep hacking, bro. Also, thank you. Appreciate it for both of you. Really appreciate it. Okay, so let's get back on this function here. So we have the game state, its mute state. We have the context, which is our LTK. That's all good. And our return is going to be the item menu result, which we need to create. So let's make that like up here at the top. And you don't have to, but I always like to make my types more to the top. Maybe it's, you know, years of C programming, C++ and all that. You get used to it. So we're going to need a couple of things here. We're going to derive, what are we going to get? Partial EQ and copy and clone. And it's going to be pub enum item menu result. And what are our variants? Cancel, no response, and selected. Curious what the difference between cancel and no response is going to be, so we'll check that out. Auto format put that nice little comma at the end for me. Love it. And state didn't come in, so we're going to have to pull that in from the super here. Bingo. Alrighty. Next up, we got a big old beefy boy here. let's go ahead and start implementing this. So we're going to get the player entity resource. We're going to get the names components. We're going to get the in backpack components. Those are going to be the first three things. So let player entity equal gs.ecs.fetch entity. Only time you've seen pub is, hold on. 7 deep with the Stony B at the local water. Nice. You know, I used to. I had to stop drinking though. You know, I don't have a problem not drinking. I have a problem stopping once I start. And it was getting bad. We're gonna read storage, which is gonna get us all our names. Don't pluralize it. I made that mistake earlier. Because like internally you're thinking we do want to call that names. Internally you're thinking plural. And we're gonna pull out read storage. Oh, sorry, I forgot the that boy there. And this is going to be in backpack. So we need in backpack to come in as well through the super here. And that should all be happy so far. Okay. Now we're going to get the inventory, which is... We're going to join up and filter. Okay, so it's a little bit of a more complex join. So we're going to get the inventory, which is backpack and names. Remember, backpack is literally just everything that is in a backpack. So every entity in the game that's in a backpack. But it could also be like monsters or something, or NPCs. So we're going to join that up, and then we're going to filter it. We're going to filter it on item.0.owner equals the player entity. Yep, and that's all we got to do there. So that gets us that iterator. And then let count equal inventory.count. Actually very easy, efficient, quick way to go ahead and just get that information out of there. I like that. This is where the ECS is actually starting to pull through quite a bit and show a lot of valuable show a lot of its value. Where we didn't have to like implement a lot to get some basic behavior here. That, I mean, yeah, I guess you might build it out of like a vector or something in a lot of game design, but it's kind of just falls into place. It's very convenient. So let me y equals, now this is interesting. I already know why we're doing this. 25 minus count over 2 as I32. I'm pretty positive that this 25 is because it's a roguelike and our inventory is going to be A through Z. We're going to use that to select whatever it is that's in our inventory. So we need to basically figure out like how many things we have if it's going to fit in the alphabet, right? So we're going to draw a box. These are the big, I hate doing these because so many parameters. Y minus 2, 31. Height is count plus 3. Foreground. Oh, that's also as I32. What is the foreground? RGB named. RLTK white. And the background is, I gotta scroll a little bit to see that, is gonna be black. Copy that and modify it because that's the lazier way. I know I missed that closer. So there we have our box. And now we're going to be printing a couple of things. So context.print color. And we have... So I want to make a comment on something. I've made this comment plenty of times. But these numbers, kind of pulling them out of nowhere. They seem like magic numbers. And in a lot of ways they are. But... what you have to do when you're doing UI, it's a lot of trial and error. Generally speaking, you will end up just plugging in some values and you'll see what they look like and you'll slightly modify it until you get something that, does what you actually want it to, that kind of fills things out in the way that you're expecting. You can do that initial design of the UI with a lot of trial and error, and then you can redesign it a second time with a more dynamic approach. Like say, let's make things based on the percentage of your screen or something, or the window or whatever. That way things dynamically size and resize. You can do that later, but typically your first go at a UI is going to be something like just hard coding in values and seeing what you come up with. And because this is a tutorial, we're not going to go through that we're not doing all that process of designing okay, we'll put this value in. Oh no, that's not good. Scoot it over by 2 pixels or 2 tiles, right? We're not going to be doing all that here, but that's why these numbers just kind of come out of nowhere. And it's like, well, where do you get that? Honestly, trial and error. That's where these things come from. But it is frustrating a little bit when you're looking at a tutorial and you just see these numbers Like, how did they know they wanted to put 18 here? How did they know they want to do this or that? Part of it, like, draw a picture, kind of approximate from a picture. If you get some kind of like idea just in your head and experience, that gives you an idea of where to start. But then, you know, you could start thinking about ideas like, oh, what we want is we want something like we did this last time, where if the cursor's on the right side of the screen, we draw the tooltips on the left. That way they don't go off the screen, and vice versa. So, I mean, you can use information like that to go ahead and say, well, in that case, we need to know what the center of the screen is, and then we make our logic based on where the cursor is at in relation to the center. Like, we can already like start deducing a lot of information from there. So we're going to join up these two, and we're going to filter them again. Item.0.owner equals player entity. No. Here. So this is very similar to what we just did a moment ago, and I want to make sure I want to actually just lock into what we're doing here. Not so. Oh no, wait, I think I was looking. Oh no, I'm looking at the right thing. Yeah, we're doing that join again. Backpack and names. Only thing we did the first time was the inventory count. I'm not convinced we need to rebuild this iterator, but hey, we have it. So we'll go with it for a moment. Context.set 17. I don't have a context anywhere. So 17, Y, RGB, named, RLTK, white. I really hate doing these context like sets and boxes and stuff because there's so many RGBs that are annoying to type. We're gonna get this character in, which is gonna be okay. So it's gonna be the open parenthesis, which almost looks funny there. So many parentheses. This isn't Lisp. Why are there so many parentheses? So we're gonna do a couple of these here. Context.set again. And this is now gonna be, oh, this is getting funky here. This last glyph, or this, no, the second glyph is gonna be 97 plus J as RLTK font char type. We're gonna have to break down what's going on here, and I will do that after we get done filling this thing out. I always try to do that when I get done with a function, a big old beefy function like this especially. I like to make sure we all understand what's going on. And as I'm typing this, as I go through the tutorial, there's a mismatch somewhere. Oh, because we're no longer calling that function, yeah. As I'm typing this, as I go through the tutorial, I want to make sure that I don't miss things out because I'm talking and typing. I'm doing so many things at once that I want to make sure I didn't miss some context as to what's going on. So 17, 18, and 19, and they're all Y as the second parameter, and then white, black, yellow, black, white, black. And then we do the CP437 open parenthesis, close parenthesis down there. This one is 97 plus J as RLTK font char type. And then context.print, yeah, so ctx.print 21y and name.name.toString. And we are good to go there. So y plus equal 1, j plus equal 1. Yeah, this is a very interesting bit of code here. Match context.key. None is item menu result, no response. Some key is match key, virtual key code, ESC. There we go. I was like, can I get it to fill in some stuff for me here? Super can. I don't want to use ERLTK there. This is going to be item menu result cancel. We're going to destructure. No, we're doing 2 no responses. I don't think we filled in the rest yet. So basically it can be escape or it can be everything else. Item menu result, no response. And we need to bring in virtual key code. Yoink. Alrighty. There's a lot going on here. Let's take a look at it and let's break down what's happening. And then let's try to make sure we understand everything here. So one thing I want to double check is this for loop. It goes through Y and J, and it's these 3 context.sets and the context.print H. Again, I'm not entirely sure that we need to do this filter twice. So we do a join, let inventory equal backpack. So it's backpack names dot join and filter item 0 owner is player entity. It's like the same thing. So I'm wondering why. I mean, what we do here is does counting consume? It does consume the iterator. That's why. I guess because we consume the iterator, but can you do that without consuming it? Can you like I don't think you can like clone the iterator. So I guess that's why. I was wondering why we're doing this join twice. The joins and stuff are really cheap and efficient in specs, which is the ECS we're using. But I just kind of get concerned about we're still having to go through the iteration twice. And I get a little concerned when I see that. I'll explain very briefly again the way the joins and stuff work here because it is interesting. Specs uses something called high bit set. And the way to think about it is imagine you have a bit set associated with each component in your game. So we have a player component, we have a monster component, we have an item component, we have a beanbag component. I don't know, I'm just making up names, right? At this point, I'm just making up names. And that's good enough, right? So, and let's say there's 5 things that we've put in the game. So we have a bit set like this for everything in the game. And actually, I want to make some of the, we're going to do renderable. So then renderable is going to be 1, 1, 1, 0, 0. And we're going to, instead of beanbag, we're going to make it, what's something that's not renderable? Crap, I can't even think of the components that we have. In backpack isn't a renderable thing. So we have in backpack. And let me go back over to that. No, where were we at again? Player. Nope, I've completely lost track of where we were at. In GUI. That's it. It's been so long since I've been in GUI. So we have in backpack. This is not renderable. And then we have some items here. So this is 0, 1, 0, 0, 0. So that thing is renderable. The monster, yeah, the monster's renderable. We have an item, and we have in backpack is, well, actually I'd want like 2 items, but I don't know, something like this. The idea is you can do a join on these high bit sets very quickly and effectively. So if we say, I want, give me everything that is a player, that is a player and is renderable. then what it does is it takes these two bit sets, it takes this one here and this one here, and it does a join. So the resulting bit set is going to be 10000, right? Because the only two that actually match up is the one here and the one here. But we could also think of a case where maybe there's more than two different things that line up. So maybe if I had a better component here, like the dealing damage component or something, that the monster could actually be using. We'll say suffer damage. Suffer damage is one of our components. So let's say back in GUI, let's say instead of the in backpack, we'll say suffer damage. And then we'll do that there and that there. So now, what if I say, give me everything that is monster plus renderable plus suffer damage. And maybe what I want to do is when it takes damage, put an effect, put a particle effect or something, right? So then we would get a resulting set, bit set of, and then this is going to be 00101. Actually, it's going to be that because the last monster here is 0 and suffer damage. So the only one is going to be this third entity here that's actually the resulting bit set of all three of these. So that's actually a really quick thing to do. You can almost think of it though as just like, I don't know what the actual complete underlying data structure is like for the high bit set, but you can almost just think of it as like that array of bits essentially, and it's probably not an actual array, but whatever it is, this is how the joins happen in specs. And so instead of having to like loop through everything, it's essentially like a bitwise union of the different things that you're joining together. So it's very quick, very efficient, and then using that, it's very quick to iterate over the resulting bit set. That's the general idea of what's happening when we do these joins, and why it's not like necessarily bad that we have to do more than one join. But of course, you still want to limit things as much as possible. Every time you have to do something extra, that's still adding more processing, and eventually it's, you know, depending on the complexity of your game, things are going to slow down, right? So that was another big aside, but I think it's fun and interesting to talk about and look over, make sure it's understood, because these things are happening all over. When we see two different kinds of storage things being smushed together with the join, that's what's going on. A joined iterator over the contents. Okay, so now let's break down this function a little bit to show inventory. So we need the player entity, which is the resource. We need the name, everything with a name component, and everything with an in backpack component. Now remember, monsters might have backpacks, so we're gonna have to filter it to figure out what's in the player's inventory, which is what we're doing here. So we say, all right, now join up everything that's in a backpack and like everything that has a name, and then let's filter it. And the item here, the in backpack component, item.0, in backpack has an owner component, or an owner field on it, which is just an entity. And so we're comparing that entity to the player entity. If they're the same, well, we know it's part of the player's inventory. And that's where we get our count. That's how many items we have in our inventory. So now Y is going to be used to determine how big to make our box, right? So we're figuring out how many things do we have in our inventory. And again, this is probably being based off of alphabet. I'm guessing it's based on the alphabet, because a lot of times in a roguelike, you open up your inventory and you have everything from A to Z. So we're probably going to be doing that. That's what it seems like to me, at least. And I think that's what we're getting down here with this J and stuff, which seems odd, but 97 plus J, I think that's what we're getting down here. We'll have to delve into it a little bit more. But this is giving us basically, I think, the height of our box, right? And then we have some values here which are essentially hard-coded in that are based on that. But like, so what we know is that, okay, from the top of our box, you know, we want to move like two tiles down and put the word inventory or something, right? So I think that's what we're seeing here with the Y-2. we're basically saying, okay, here's the top of our box, go down like 2, and then put the text inventory. And then y plus count, which is going to be all of your items. And then right below that, you say escape to cancel. So then that leaves a big like block in the middle, if I'm understanding that correctly. Actually, y minus 2 is going to be going up. Yeah, so y minus 2 is going to be up, and then that y plus count is going to be going down. But we're leaving like a big gap in the middle there, basically. And let me just double check something here. Count plus 3, yeah, okay. Y minus 2 and y plus count. There's a lot of like funky stuff going on here. I want to make sure I grabbed everything correctly. So then what we've basically set up here is in that empty space, we're going to go back through the inventory now, and we're going to populate that inventory with all the items that we have. So open parenthesis, and then 97 plus J as our LTK font char type, and then close parenthesis. What this is setting is the key that we're going to be pressing. And what I'm pretty sure is happening is, what is J? Well, J starts at 0. Yeah. So 97 is A, right? It's like ASCII. 97 would be A, and it starts at 0. So 98 would be B, and so on and so forth. So we loop through that entire inventory, and it just keeps... So I was confused in my brain. I accidentally thought J was a character, but no, J is just that value we set up here, starting at 0. And 97 is just know your table, know your character table. But we've seen it before, and I'd like to pull it back up actually. Let me find it. CP something. Yeah, don't Google that. Dwarf Fortress character table. Let's take a look at the browser here. And so here's the big Dwarf Fortress character table. And we can find A somewhere. There's capital A. Here is lowercase, and we see it's 97, right? So that's all that really matters here is we're getting that, and then every time we iterate through, we're increasing that J value. So it's going to add 1 to this every time. And that's populating... That's basically telling us, okay, this is what button to press to do the thing, right? To do whatever inventory thing you're trying to do. So let's go back over here. Again, that's a lot to break down on this function. I want to make sure it's understood by both myself and yourself. So then we just print whatever the item name is. So we've printed parentheses with the letter in it, in between them, and then we print the item name. So now what we're trying to do here, we have a dummy match statement, which isn't actually picking the item yet, but what we want to do is figure out a way to determine which item we've set here, and we're going to eventually account for that here in the match statement, right? But for now, we say if they don't press a key, it's no response, and if they do press a key and it's escape, we call it no response, which seems odd, but or no, if they press escape, it's cancel. I was looking at the wrong line. And yeah, if they don't press, or anything else, whatever, I could press any letter, I could press anything else on the keyboard, it's no response for now. We're going to change that. So that's a big, beefy function. A lot to break down, but I think we got it. So we'll also read their summary now. This starts out using the filter feature of Rust iterators to count all items in your backpack. It then draws an appropriately sized box and decorates it with a title and instructions. Next, it iterates all matching items and renders them in a menu format. Finally, it waits for your keyboard input, and if you pressed escape, indicates that it's time to close the menu. If you cargo run now, you can see the items that you have collected. So let's take a look at it. I feel like we still haven't done something, but let's take a look at it. Are we red? Are we good? Ah, we are good. Okay. So let's find a potion real quick. Let's hope I can get one quickly this time. Another, like, empty... Oh, there's one. Another empty dungeon. Okay, it's closing for some reason. Every time I press the button, it closes very... We could see its health potion, but I may have missed something here in what we're doing because I shouldn't have to do that. I should be able to press escape to cancel. So let's see if there's a bug indicated in the tutorial. No, I don't think so. So let me double check some of what I've done and make sure I didn't miss anything with the way I'm juggling the states or something. So the first place I want to go is... it's probably... yeah, it's probably this. If show inventory is cancel, it's awaiting input. Otherwise... Otherwise, nothing really. Yeah, so then this unfortunately does make it more reasonable to do, well, put it this way. I can't really bubble out unless we change how this is functioning. So even though I was a bit stubborn on it, we're going to do this here. So we're going to say new run state equal. And every time we're bubbling out, we're going to do this instead. Oops. Quick change, but I think that might be good enough to make it happy. Oh, and player input. Put that right there. Okay, let's try running again now. Give me a quick potion. Come on, game. These don't look like potions. Oh my goodness. I'm dead. Well, there was a potion. I got what I wanted, but there's so many monsters. Come on, we gotta test the inventory. I mean, I guess we could test it without an item, but I want to see it with an item. Okay, come on, really? Another room full of dudes. Alright, we have a potion. No, I'm not getting anything now, am I? What have I broken? Okay, well, I'll take a closer look. Let's figure it out. Let's debug a little bit. So I want to see where the item menu result cancel is at. New run state. So if GUI show inventory self context is item menu result cancel, new run state is run state awaiting input. I think all these other run states are probably fine. Nothing should have changed, right? But that's completely... The inventory wouldn't even open now. Can I open it? Oh, wait. Why wasn't it open? Hang on. Did I die and I just didn't notice or something? Wait, it's just totally working now. I didn't change anything and now it's working. What? That's almost more concerning, is it not? So I will say this, my initial inclination was that I was saying we're taking a turn every single time we don't press anything in the inventory, and that's why it was like flickering on and off like that. So that actually makes sense. Yeah, I mean, I don't know what else to say on that. Like, it was a quick fix to actually stop it from closing the inventory. It was just the way I was handling the match there. I'm doing it my own way a little bit, but as for why the inventory wasn't working a moment ago, as it was not even opening, I have no idea. We have a potion though. I can press A, it does nothing. I can escape, it works. Let's go ahead and rerun it. Inventory works. Although some stuff is drawing over the inventory, which is a bit odd. I'm gonna double check some stuff in their code base as well. Not now, but I'll do it before next time. Because I don't think we're having that problem with the player as well. What's happening is we're drawing the map after the inventory. So show inventory, and then we draw map. If we move the map first. We just put it up here. Yeah, we don't have any borrow issues or anything, so let's check it out. Whatever you draw, in whatever order you draw, is how it's going to appear. Well, that's obviously fine. We need to uncover that part of the map. Don't y'all try to kill me. Yeah, that's better. Okay, so we've got that showing up where it should now. The player's showing up over the inventory though, so we want to make sure we get the player rendering. Basically, we want to draw the map, then draw all the other stuff, then draw the inventory, right? So I think we could actually move a lot of this above this match. Like, can we do all this? Delete the dead. I'll work on modifying some of this later. Oh yeah, no, I was afraid of that. Yeah, we'll not worry too much about that right now, but I'm gonna check the order of it later. Between streams. I don't want to get down that rabbit hole right now, but I would like to fix the drawing order and make sure things are showing up as intended. Alright, so, but I am going down a rabbit hole, so let's go ahead and make sure things are good. So the inventory works. Yeah, so we've cargo ran it. Okay, everything's good. All right, sorry about that. So yeah, we do the filter. If we press escape, we can close the menu. Yeah, it iterates all of them, renders in a menu format, blah, blah, blah. So if we cargo run, we can see the items we've collected, and there we have it, right? So now we use items. We can display our inventory. Now that we can display our inventory, let's make selecting an item actually use it. We'll extend the menu to return both an item entity and a result. Okay. Okay, I see. So there's going to be... these are always a little annoying because I got to go line by line and make sure no tiny changes happen. So forgive me, but I'll do my best. So we have item menu result. We're also going to get option entity if they selected something. And then I assume most things are going to be the same until down here. So none is going to be no response, and guess what? None. Oh my goodness. Escape is going to be basically the same. Cancel and none. Item menu result. Well, for everything else, yeah, we're going to do some work this time. So let's do some work. So let selection equal RLTK letter to option key. So that's actually something that's built into the toolkit here. So we'll take a look at it in a moment. If selection is greater than -1, which is odd, I guess it's 0, and selection is less than count as I32, return item menu result selected, and some equipable selection as usize. And then that tells me we do need something else above, right? Item menu result, no response, none. So we don't have equipable, so we're gonna have to deal with that up here. And it's just before, it's just after the context.print. Oh no, not yet. Equipable.push entity. So we're going to be able to index into it. So then just before mute J is where we actually declare it. So let mute equipable vac entity will vac new. And do we need anything else up here? We do need entities. Let entities equal gs.ecs.entities. And we need to get that entity by including it into our loop here. So it's going to be for entity pack name in entities, backpack and names, right? Entities, backpack names, and I don't think really much else changes. Although, no, that's no longer item.0. It's item.1. Okay. Yeah, we're bringing in the entire tuple. Okay. It seems happy. So I want to take a look first at letter to option. For A to Z menus, translates the keys A through Z into 0 to 25. So it's a helper function that just it lets you use it for indexing like we've done here. We use this selection variable that comes from that to index into the vector. Very easy, nothing really special about it. You could do it yourself, but it's just a helper function. Stop you from typing the boilerplate, I guess. So then in main, we're gonna have to clean up a little bit. So a lot of bit. Let's just delete that and let's just go and like start over. Let result equal GUI show inventory and itself and context. Match result.0 GUI item menu result cancel new run state equal run state awaiting input. Can I get some help on my match here? Because I'm lazy. So next up is no response, which does nothing. And then lastly, this is where we got all the new goodies. Let item entity equal result.1.unwrap. Let name. I don't like the unwrap. Hopefully we'll clean that up one day. Self.ecs.read storage. Although you could argue that this is one of those cases where maybe something has gone horribly wrong and you might be okay with crashing. I mean, I kind of like when a game can handle that kind of stuff without just straight up dying, though. So Cataclysm Dark Days Ahead actually does a good job at... I don't know. Yeah, I've never actually seen the game crash. I've seen errors pop up, and the game is just like, hey, I don't know how to handle this, but you could just keep playing. You could ignore that, and it's fine. I actually really like that. I can appreciate that. You know, it would really suck to lose a bunch of progress in a game like that because the game decided just to die and it was out of your control. All right, and then last, We're gonna do new run state, awaiting input. I feel like at that point it's more like you've selected something. All right, so let's break down what's going on here. If they cancel, we go back to waiting input. No response, we do nothing. They're still in show inventory, basically. And if they've selected something, okay, I guess it makes sense to go back to awaiting input. If they've selected something, then we pull the entity out of the result that we got from the show inventory. And we get names and we get game log. And then we use that to actually push a message into the game log to say, hey, you try to use a thing, but we haven't written the code to do it yet. And then we say names.get item entity. So that's literally just, we have the entity, now try to get it from our names components that we pulled in right here, and use that as our format, like into our format string. And then we go back to awaiting input. So it's like the player turn again, basically, right? Yeah, and that actually makes sense now because we don't actually use an item, so we don't want to give the monsters a free turn. We'll probably change that later. So we'll just go ahead and run it, and we'll see that we should have a thing in the log that says we can't use an item yet because it's not written. Perfect. Yeah, you try to use a health potion, but it isn't written yet. Alrighty, cool. That all worked very, very nicely. That was an easy run. Thank you, RNGesus. Okay. So pretty straightforward change there. So now, as we see here, if you try to use an item in your inventory, you get a log entry. You try to use it, but we haven't written that bit of code yet. That's a start. Once again, we want generic code so that eventually monsters might use potions. So we're going to cheat a little while all items are potions and just make a potion system. We'll turn it into something more useful later. So we'll start by creating an intent component in component.rs and register it in main. So I want to make a comment on that real quick because I think that's actually very important to approach development kind of like this. You might call it rapid prototyping. I don't know, you might call it a lot of things, but the idea is it's really easy to over-engineer something. And a lot of times when you're trying to build out an initial working version of something, it's probably better to get something working that then you can refactor and turn into something more generic, turn into something better. But if you start out by trying to architect the perfect system, you can often get like way down into the weeds and you can try to add way too much functionality for what you actually need. I really like, you know, the mention of this approach. Like right now, all we have are potions. We don't need to make some big crazy generic system because all we have are potions, right? And of course, like we're probably going to want to change that later. We know we're going to want to change that later. But for now, let's get something working because something is better than nothing. And then we can expand that as needed and then turn it into that generic function or that generic behavior. So I do like that. It's again, very easy to over-engineer, over-architect, whatever, beyond the needs that you actually have for your program. Now, I'm not saying to not think about the future, but particularly if you are new to something like game development, or if you're new to any particular thing that you're working on, it's almost better to start with the little baby steps and get something working. And rapid prototyping, get something. You know, one of the best things you can do with game development if you're getting started is just get a thing moving around on the screen, because that's further than a lot of people ever make it. Because a lot of people, they say they want to do it, but they never actually like get around to even doing that much. And if you've got something moving around on the screen, you're probably doing better than a lot of people who say they want to do game development, but they never do it. And that can go for a lot of things though, right? Baby steps, rapid prototyping, something is better than nothing to start with. And then once you have more knowledge, you can start building out something better, more robust, etc. I don't think I need to talk about that anymore, but I just kind of want to drill that home because I do think it's important. And I think it's important not to be. Actually, the last thing I'll say on it is the over architecting thing is part of the reason a lot of people don't get anything implemented, because they think, oh, well, if I'm going to make a game, I've got to know how to build an entire engine. I've got to know how to do this and this and that and that and that and that. And they're overwhelmed by all the different pieces that they don't even start from the smallest pieces. They don't even start from the easy things that are accomplishable, right? I think that kind of gets the point that, gets to the point of what I'm trying to say. So we're going to go ahead and start adding these components and stuff. So what do we need? We need component and debug, but I'm lazy, so we're going to, I'm going to be even lazier. We're going to copy and modify this. Component and debug, no clone. And this one's going to be called wants to drink potion. And it's potion. And there's no collected by to worry about. Okay, and then we got to add it, we got to register it in main. So here we go. Wants to drink potion. Cool. Okay, we're done. It works now. No, it's not that easy. So we're going to go to the inventory system. Where are we at? And we need a potion system in here. So pub struct potion use system. And again, I'm going to be a little bit lazy here. Copy some of this and modify it. That is maybe a little more prone to error, but we'll figure it out, So we're going to impl system for potion use system. System data is going to be read expect entity. That's our resource for the player. Write expect game log. Good. And then entities. And write storage wants to drink potion. And then we need the name. Let's scoot that up. We need potion. So write storage on wants to drink, read storage on name, read storage, on potion, which is not used yet, so we'll grab it in a moment. And then write storage on combat stats. I forgot all about combat stats, but we need that because that's where our health and everything is stored. I don't really want crate on those. We can pull them in from super. And we need potion. It's sorting them and stuff too. I like that. Okay, so now we need the function that we didn't implement. Do a little work for us there. And we got to destructure all this. Do I want to type that out? We'll do it. Let player entity, mute game log, entities, mute wants drink. I like where that's going. Yeah. Potions, mute. See, I don't even know what's combat stats. Yeah. So we got all our goodies unpacked from that big old tuple there. And now we want to say for entity drink stats. So we're linking up the three. And wants drink and mute combat stats. Dot join. So all entities that want to drink and have combat stats. Let potion equal potions dot get drink dot potion, which is just tying the entities together. Match potion none some potion. I will say just small, criticism or whatever. If we don't need to do anything with the none here, we could do an if let. less boilerplate. I don't know if we're going to add anything to the none, but if lat would work very well here. So stats.hp equal I32 min stats.max HP or stats.hp plus potion.heal amount. Quick and easy, clever way to just clamp that where we need it. So if this goes over the max HP, then it just picks the min value, which is max HP. If entity equal player entity, we're gonna do something with the log, because we don't really care so much about logging what the monsters do. You drink the blank, healing blank HP. I mean, you might actually care about what the monsters do, though. So names.get drink dot potion dot unwrap dot name potion dot heal amount. Big old beefy thing there. I'm just save and it'll format it. It's a little bit better. And in the end of the if, we do entities dot bullet drink dot potion dot expect delete failed. Yeah, we probably aren't going to be happy if something fails, but again, I don't know if we want to crash. All right, so at the end of that once drink dot clear here's the contents of the storage. Okay, yeah, because I guess we've already looped through all the things that once drinks. Okay. And then we're going to register that in our systems. So here it's going to be let mute potions equal potion use system potions dot run now and self.ecs, just like all the others. But potion use system isn't here. Why not? Where did that go again? Inventory system. Because now it should pull it in. Yeah, because we didn't actually have that before. Although item collection system, where did that come in? Did I pull it in up here? I did. We don't need that. Yeah, I was like, wait a minute. Something weird's going on. Okay. So let's break down a little bit about what I just did. Inventory system. So to use potions, what do we need? We need read access to the, we want the player entity. So we get the player entity resource, we get the game log, we get all entities, we get write access to wants to drink potion, we get read access to all names, we get read storage to all potions, we get write storage to all combat stats. We rip all that data apart, so we have it in variables, and then we say we join up all entities with all things that want drink and all things that have combat stats. So something that doesn't have stats can't drink, basically. That's what we're saying. And then we want to mutate combat stats because that's where the health is at, right? That's where your health, power, all that stuff is stored. So we got to mutate that. So now we get the potion. And we do that by saying, so this is, again, the oddity here. I mean, I don't necessarily think it's that odd, but it's the thing, if you don't understand the ECS that we're using here, if you're just now like tuning into this or something, and you don't know specs, you don't know what's going on, the thing that's a little odd here is the indirection. So potions is all the potion components in the game, .get says fetch us a specific entity, tries to read the data associated with an entity, and then drink.potion is an entity. So drink is that wants to drink potion. So we're crossing between two different entities now. This thing here that we've defined in the for loop is an entity with combat stats that wants to drink, and drink.potion is the target. That is what it wants to drink. So this is how we're getting access to a different entity. In other words, the target entity of the one that wants to do the drinking. And then we match on that potion, and if it's none, we do nothing. By the way, this is what I was saying, an if let would work here. You could get rid of the none. You could do if let some potion, somebody, potion, and then we could go in here and do that. Basically, that if let syntax is a shorthand for saying basically this same thing here, this match statement, but we know we're never going to use the none here, so this just takes the potion part out of the sum. So this here, and then whatever's in the brackets here, or in the braces here, can go in here, and it's identical code. So looking at the two here, you could, pick your poison or potion or whatever you want to pick. But the if let sum reduces a bit of boilerplate. We're not matching. We don't have to put a match arm that we're not using. I'm going to go with the match because I don't know what the plan is for the future, but just making note of that. So we get the potion, we match if there's a potion. The new stats.hp, which is our current health, is equal to the minimum of our max HP or our current health plus however much the potion heals. And then if it's the player entity, we log that they drank the potion, and then we delete the potion because it doesn't exist anymore. So entities.delete just straight up is gone. And then once drink.clear. So by the time we go through this for loop here, we've done this for every once drink component. So we know we don't need them anymore. So we just clear all of it. Is gone. And that's it. That is a drinking system that should be mostly working, but it looks like there's going to be a couple other things that are going to come up here in a moment, some surprises. But we are coming to the end of this, but there's still a bit to go, so let's see what happens. I've already registered it in the systems, and it says, like other systems we've looked at, this iterates all of the wants to drink potion intent objects. It then heals up the drinker by the amount set in the potion component and deletes the potion. Since all the placement information is attached to the potion itself, there's no need to chase around making sure it's removed from the appropriate backpack. The entity ceases to exist and takes its components with it. Testing this with cargo run gives a surprise. The potion isn't deleted after use. This is because the ECS simply marks entities as dead. It doesn't delete them in systems so as not to mess up iterators and threading. So after every call to dispatch, we need to add a call to maintain in main.ecs. Main.ecs? You mean main.rs? Not main.ecs, unless we're writing a different language. Okay, so we'll take care of that. But I want to take a look at the bug right now. So let's try to find a potion if we can get one. Hey, I saw that. Give me that. Drink. You try to drink it, but it... Oh. Still have that... Oh, yeah, we haven't actually changed the... Hold on. We haven't changed the logic here, have we? Yeah, no. Did I miss something, or... Yeah, no, we're gonna have to update that. But I think we did actually use the potion. Okay, let's try one more time. I think we are using the potion. That log is incorrect, but let's find a potion. Let's take some damage. And let's find a potion. Yeah, I think the log is just bad. Nope, running away from that. But not that. Come on, give me a potion. I need to survive. Oh, not surviving today, am I? Oh, I am dead. Rip me. F in the chat. Come on, I need a quick potion. Okay, there we go. Alright, so I am hurt. They are hurting me, though. Okay. Try to drink it, but it isn't written yet. Okay, so there's still a missing component here. Actually, literally, I think there is a missing component. Yeah, we are literally missing a component. Okay, that's all it is. So take a little bit of umbrage with the tutorial text because we can't cargo run it. Like, we can't really do that yet because we don't have everything in place. Unless I'm missing their intent, but here we are. So what we have to do is add the maintain, like we already heard about, every time we do, every time we run systems. Maintain. Okay, so that seems easy enough. Let's go ahead and do it. So run systems, and then what is it? self.ecs.maintain. I'm going to copy that, and I can just go blop, blop. Okay. And finally, we have to change the run state show inventory handling. An item was selected, we create a wants to drink potion intent. So on selected, where the log was at, or, well, this whole thing, names, game log. Okay, we're not logging. Yeah, no, we actually, yeah, we moved the log into the potion system, right? Where the hell did that go? Hold on. Inventory systems. Yeah, the log is in here now. You drink the potion. Okay. So, back to main. We can kill that game log right there. And that one. So now we want to say, I guess we don't need the name either. So we have the item entity, let mute intent equals self.ecs.write storage. And it's going to be turbofish wants to drink potion. And then we want to do intent.insert self. Oops. How did I get quotes in there? self.ecs.fetch entity wants to drink potion. We're going to feed it the item entity. Expect unable to insert intent. Cool. Alrighty, and the new run state is, this is what I called earlier, player turn. Now we're actually doing something, so it does count as a turn, which makes perfect sense. So now if we run, we should get the desired intended behavior. So I'm going to scoot my browser around and stuff and click back into our game here. Let's try to find a potion, hopefully quickly before I die. These are not potions. I have no potion and I must scream. If you're wondering what the purple thing on the screen is, that is the last known mouse cursor position. As I drug it off the screen there, drug it off the window. But we do have mouse look. We can mouse over an item and see what's in the tile. Or mouse over a tile and see what's there. I'm almost dead. And an orc is here to finish the job, huh? Unless I can get a potion. No! In my dramatic fight for survival, I get too close to him. No! No! Oh, well. Oh, I'm keeping him from hitting because I'm moving away. Is there one still in this hallway? No, we can get through the hallway. Wow, how am I still alive? Well, I've explored the entire map and there was not a single potion. You know what that calls for? Alrighty. That's how randomness works, am I right? That was actually fun though, just trying to stay alive, escape. Oh, yay, potion! Okay, now we need to get hurt. Someone hit me. Normally I gotta pay for that kind of service though. Alright, we're a little hurt. And we actually have 2 items now, we could see that. Yeah, we're healed. Let's try using another one. And we used it, but it does nothing because we actually didn't need it. So I think that would be a good thing to put in place, is to be like, hey, you don't need that potion right now, and cancel using it. Maybe we'll do that at some point. All right, so everything so far seems to be working pretty well. Can't complain. So what's next? Dropping items. Yeah, this is a beefy section, so we're only doing this one today. No ranged stuff, because that's actually pretty long as well. But, you know, you got to take your time. I don't want to, like, rush. So dropping items. You probably want to be able to drop items from your inventory, especially later when they can be used as bait. We'll follow a similar pattern for this section. Create an intent component, a menu to select it, and a system to perform the drop. So we make our component wants to drop. We add another system to inventory system. And we register the... We also got to register the component. Let's not forget to do that. Oh, it actually does mention registering here. So yeah, we'll do basically all this. We'll register it in the dispatch builder. And we'll add a new run state. Yeah, there's going to be a lot of stuff here. But this is actually almost like... There's a lot of very similar stuff. Drop item menu is actually going to be really similar to the other menu. Maybe similar enough that I can copy paste and just modify a couple things. I think we're just changing the components and stuff that we're using. Not here though. Yeah, this is like identical. We'll probably refactor the menu at some point. If it's so similar, we'll probably refactor it. That's another thing though. All right, let's get started adding all this stuff. So what do we have? Components. Here we are. So we have wants to drink potion. We'll derive. There's a lot of things listed here, and some of these are not going to be needed. So we have component debug, clone, the convert save load. I did find that in another section of the tutorial when I was skimming through, but we don't need that yet. So we want to drop item, and it's an item of type entity. So we're gonna go to main, and we're gonna register that bad boy. Wants to drop item. And then an inventory system, wherever that's at. We're gonna need another system here. Item drop system. And we're going to impl for item drop system. There's item collection system. We're going to try and cheat a little bit. A lot of this is going to be similar. So we're going to replace this with item drop system. And, well, what do we need? Read expect entity, write expect game log, write storage. Well, no, next is entities. And then write storage wants to drop item. And then read storage name, write storage position, write storage in backpack. Let player entity, mute game log, entities. And there's going to be mute once drop. Mute positions, names, no. Oh, names is before positions. Names, mute positions, mute backpack, all that equal data. And then there's some mad stuff here because we are doing different stuff. So there's our big ol' let. And then we're going to say for entity to drop in, and what's our join here? Entities and once drop dot join. All right, now this is going to be a little bit different, so I'll probably kill most of this loop. I think editing it's going to be annoying. So let mute dropper position equal position x y. Oh, it's a very long time since we had to do that. So we're making a position for where the dropper is, whoever's dropping the thing, and then let dropped position equal positions dot get entity dot unwrap. Don't like unwraps. Same thing here for y's. We'll get the x and y values and set them. For the record, once again, this is Rust. So if we wanted, we could say, actually, I would say a safer thing to do here would be to use like an if let. No, actually, I wouldn't even do that. I would do a match here. I would do a match. I would say let dropper position. Doesn't have to be mutable. I would say let dropper. Here's what I do. Let me just show it. Here's what I would do. Let dropper position equal, and we go in here and we say match positions dot get entity dot, and then our match arms dropped position, and then here we say position, and then we fill our struct fields with dropped position.x, and then again for y. And then what I want to do is actually just copy this, and we're going to do, actually it would be quicker to do this way. 0 and 0. And then boom. So it doesn't need to be mutable. And what we've actually done is we've removed the unwrap. So what will happen is it'll default to 0, 0, however. And if we don't want to do that, that's fine. We could make some other decisions, but what we have done is removed the unwrap, so if it does fail, the game doesn't just straight up crash. But what we could do here is instead of this, we could like return some kind of error or something. We could put some like safety checks, some sanity checks in here, right? What is going on here though is almost asserting by use of the unwrap that this thing gets initialized. And it's not going to be 0, 0. So that's more how I would do it. Just thought I would do that real quick. Oh, missed home row. Okay, so now back to this. Positions.insert to drop item. Position. So X is dropper position.x. Y is dropper position.y. And do we do an expect here? Yes. Okay, and then what? Right after this, we backpack.remove to drop the item. If entity equals player entity, gamelog.entries.push format, and you drop the blank. You drop it. Drop that hot dog. All right, so we have to get that, which means we have to unwrap, and then we have to do .name. We've done that a handful of times, so I've gotten used to typing that. Close that. Once drop.clear, that is the same. I think everything here is pretty much happy. And then we'll register it in main. It's crazy because like we didn't really do a lot to enable dropping items. There's not a lot going on there. I'll go over it in a moment. But that's very minimal code. Let mute. What are we going to call this one? Drop items. Okay. Drop items equal item drop system. Drop items dot run now and self.ecs. We need a new run state, which we briefly glanced at earlier. It's going to be show drop item. And now there's going to be some anger because we're not doing exhaustive matches on that. In player, we're going to add a D command. Show drop item, if they press that. So then that sets our state here on the one we haven't matched on yet. So we're not going to do that quite yet. We're going to go ahead and go to the GUI and add the new function. And this is the one where I said I'm going to just try copying this whole thing. And we're going to see if it's easy enough to modify. So instead of show inventory, it's going to be drop item menu. And it's going to take mutable state, it's going to take mutable RLTK, and it's going to do the same thing in option entity and item menu result. We're going to get the player entity, we're going to get the names, we're going to get the backpack, we're going to get the entities. We're going to do the inventory the same way. We're going to get the count. Y is 25 minus count over 2 is I32. Yep. 15, Y minus 2, 31. Count plus 3. Let's see, white, black, yellow, black, yellow, black. Yep, that's all the same. We're going to change the text here to drop which item. Escape to cancel is still good though. 18 y minus 2 and 18 y plus count is I32 plus 1. It should be like the exact same. We're like barely changing anything. Let mute equipable. Okay, let mute J. It just bothered me that it was called equipable because I'm like, we don't have proper equipment yet. That's a interesting name for it. So in here we have 17, 18, 19. Same Y on each. White, black, yellow, black. White, black. With the 97 plus J, just like before. We have the same filter and stuff. I didn't even look at it. That's actually... No, that's the same. Yeah. Entities, backpack names. All the same. No difference. As I suspected. The part where it's going to change is now down here. So match key. That's the same. Actually, is it going to change? I don't think so. Escape. Cancel none. Let selection is that. If selection is greater than -1 and selection is less than count. Return selected. Some equipable. Yep, that is all the same. Very, very easy function. Just had to make sure it was all identical, but I didn't see any reason. This is why I said we're probably going to abstract the menu out at some point. The last tutorial I did abstract the menu out, but this one has not yet. Actually, we're going to be lazy here even. Drop item. And we're going to see what needs to change. So we're going to get GUI drop item menu. And we're going to match on the result. If they cancel, we await input. If they no response, we do nothing. If they select, then we let item entity result.1 unwrap. Let intent, ECS, write storage. Now this is going to be wants to drop item. And then instead of this, it's going to be wants to drop item. And instead of potion, it's, oh my god, instead of potion, it's going to be item entity, unable to insert intent. All that is the same. Why are we mad? 3 were supplied. I messed up something. Let me take a look. Self.ecs .fetch entity. That's good. Oh, I see what happened. That auto filled in. There we are. That auto filled an extra thing in there. And that's it, right? Wants to drop item entity, expect unable to insert intent, new run state, player turn. So we've dropped an item. So if we cargo run, we can now drop an item. And the tutorial's like, here's a shot of rather unwisely dropping a potion while being mobbed. If only I could find a potion. You know what a good thing to do is to actually force spawn one. All right, so we have it. We can see the inventory. We can... I'm pressing D and I get inventory, but I did drop it. I think I missed a... yeah, I think I mislabeled something. Let me go back to the GUI. I mean, it still says inventory. Why? What's odd is, which function is this? This is show inventory. Drop item menu. It should say drop which item, not inventory. Oh, apparently it does now. Wait. What? Drop which item? Here's my inventory. Here's drop. What? I didn't change anything. I can open both. Am I just seeing something wrong? All right, well, we could drop it. It's there on the ground. Drop the health potion. We could pick it up. Drop which item? I mean, I am really tired. I slept like maybe 4 hours last night. Maybe I was seeing something incorrectly. It's okay. It's working. It's obviously working. Okay. So let's click back over. We're almost done here. So yeah, if we cargo run, we could press D to drop items. Here's the dude dropping when there's like dudes just swarming him. It's crazy. Okay. Also, apparently when I mouse over that, it lags. Render order. You've probably noticed by now. See, told you. You've probably noticed by now that when you walk over a potion, it renders over the top of you, removing the context, or it renders over the top of you, removing the context for your player completely. We'll fix that by adding a render order field to renderables. That's a good way to do it. Yeah. Oops, sorry. I know that looked terrible. So renderable is in the good old components, way up at the top probably. It's one of the first ones we did. And pub render order I32. And a bunch of things are going to get mad in the spawner. Your IDE is probably now highlighting lots of errors for renderable components that were created without this information. We'll add it to various places. The player is 0 to render first. Actually, wouldn't it be render last? You render it last. It's like painting over, right? You render like a potion and then the player second, and then the player shows up over the potion. That's how I interpret that. Fill struct fields. The health potion is going to be 2. Who else is mad? What are we on? The monster? Okay. They are 1. And the player is 0. Also, I would argue that if we're never going to go negative, we should use a U, not an I. Unsigned. And then to make this do something, we get to go to our item rendering code in main, add a sort to the iterators. Map.visible. Okay, I was like, I just had to find out where I'm at. So let mute data equal and positions and renderables dot join dot collect vec. Okay, so we just get a vector of all the positions and renderables, and then data.sort by. Let's take a closure here. I was doing this at work today. I was doing a lot of sorting by at work today. Render order.cmp. I may be writing a lot of Rust at work, even though I'm not supposed to, but my job is not a Rust job. I just have a bunch of stuff that I have to work with, and it's code that only I'm using, so I'm writing it in Rust. Why not? We're position and render, and now we don't do that because we've already made the iterator and sorted it. So it's just data.iter. And I think everything else is mostly the same. Let index equal map.xy, blah, blah, blah. So if it's visible tiles, then we render. Yeah. So we say, no, we're comparing B to A. So I think we are sorting it in a reverse order by doing that. I think if you wanted to go, yeah, I think if you wanted to have the player show up under things, you would do a.1.renderOrder.compare and then B. But because we do B and then A, we're going to be kind of reversing the order. I think. I've never tried flipping them. So that's all good. What about the inventory? player still shows up on top of that, so we got to make sure we draw that at the appropriate place. Are you gonna make me like cheat spawn a potion? We could do that. I mean, we could hard code in a spawn in a particular room as a way to just test. Of course I'm dead. Or I could just launch the game over and over until one shows up. There's one. All right, that definitely is working. Drink that because I can. Now let's swap this from A and B. Now let's see if my hunch is right. I've never tried swapping them. Anytime I've done sorting, I've done A and then B. I've done them in the normal order there. But let's see what happens. Let's find another potion and see. Yep, that's all. So again, their description I want to disagree with. We're drawing the player last. We want the basically what you do is you draw the potion, and then later on you draw the player, and whatever thing you drew last on that tile is what actually shows up on the screen. So you do draw the player last. The player has the highest priority, but that means they get drawn the latest, if that makes sense. Wait a minute. Oh, okay. No, there's a little thing I didn't read, but we're done. Yeah, let's read this last little bit here. I don't think I need to comment much on the code here. It's pretty straightforward, but that's really it. Your IDE's highlighting places where renderable doesn't have the stuff. So he just describes player. So player 0, and that's where they say render first. I disagree. It's render last. Monsters 1 and items 2. So for example, in the player spawner, you put 0. Excuse me, sorry. To make this do something, we go to our item rendering code, add a sort to the iterators. We reference the book of specs for how to do this. Basically, you obtain the joined set of position and renderable, collect them into a vector. We then sort that vector and iterate it to render in the appropriate order. In main, replace the previous entity rendering code with this bad boy, which we just did. So pretty straightforward. I don't think there's much to comment on. Just take a closure with A and B, and then give a compare. So this actually is a compare type, by the way. If we go back to the code here, the CMP, or if we actually look at sort by, it wants a compare in here. And so when we do this .cmp, not compare, ordering, excuse me, it returns an ordering between self and other. So that's actually like a specific type that we're getting back here. If you can't just do like, I don't think you can do like b.1.render order less than a.1.render order. Yeah, so you can't do that. Expects standard compare ordering, and it found a Boolean. So just a note, if you're using a sorting, like if you're doing a sort on an iterator, that's how it works. Okay, so that's it. Bit of a lengthy one here. This chapter's shown a fair amount of the power of using an ECS. Picking up, using, and dropping entities is relatively simple, and once the player can do it, so can anything else if you add it to their AI. We've also shown how to order ECS fetches to maintain a sensible render order. That's it. Very anticlimactic. Climatic. Well, no, climactic is, yeah, climactic was right. I'm tired, okay? I already said it. Starting to get to that just like fading point. I need to shower up and stuff after this and get to bed. So next time is going to be ranged, like just for comparison, look at the scroll bar. What we just did, that's a pretty small scroll bar. Ranged is not that much bigger. That's why we're not doing it today. it's going to be another pretty lengthy section. We're going to have ranged combat. We're going to have the scrolls and stuff in, just like that last tutorial I did. And even saving and loading, I think, is a it's a little bit longer than the ranged scroll one. So some of these tutorials are going a bit beefy. Maybe with ranged and saving and loading, maybe I can do them in one session because it's Monday. I can start the stream earlier. It's an easier day for me. So we'll see, but I'm not sure yet. But that's going to be the idea. That bare minimum, we're going to do ranged scrolls and targeting. Beefy. Beefy. All right. I don't know if there's anything else I wanted to comment on here. Other than I want to just double check a couple things. I'm going to do it off stream, but I want to double check a couple things with the systems, because it is going to matter which order you run some of the systems, I think. Definitely quite a damn bit. Yeah, it's I mean, it's a lot. Like, and I said before, I don't want to like try to cram more than necessary. Like, I want to try to retain and pick up information. And it's also why you see me stopping and like trying to break down functions and really understand them, right? Because I'm trying to retain and soak in that information. Again, if I just wanted to get through this as fast as possible, I would copy paste the code, right? So what's the point of that, though? You're not going to learn anything. If you just like, again, I always say this, but if you are doing a tutorial, you need to be writing the code yourself, you know. That's the most important thing. And then you want to also do other things related to what you did in the tutorial. You want to then like step back and write something of your own that uses the techniques that you did in the tutorial. And that's how you're really going to learn the stuff. But the first time, like if you're following that thing, type out basically everything. Like, I mean, sometimes I get a little lazy and it's like, let's just copy the imports because I don't need to type out every single import, because most of the time it's going to do the imports for me, right? Like, I'm going to start typing and it's going to autocomplete it. So most of the time it's not a big deal, but I say, you know, just so I don't have a bunch of red or I don't have to deal with it, I'll just straight up copy those in. What's going on, Jaeger? Good to see you right before I wrap up. Hope you're doing okay. Show you the progress real quick though. We got us a combat system. We got items that work now if I can get lucky and find a potion. No, I'm finding goblins and stuff though. We got some good progress going though. Pretty fun stuff here, Jaeger. How you doing? I was just talking about how next time we're going to go into the ranged like spells and scrolls and stuff, which is going to be an extension of the item system. They're going to be scrolls that we find on the ground, and then once we pick those up and use them, we get a new targeting system in place, and that targeting system is going to allow us to have a lot of fun. Right, because then you could also use that for like a ranged weapon, like a bow or something. So pretty cool stuff. As I was saying a minute ago, and I got sidetracked, I want to just take a look off stream and make sure there's not too much coupling or make sure like not too much depends on the order in which we run systems. There may be, I'm not sure. Yeah, I mean, I think it makes sense you want to run melee before damage, right? You want to run that before your damage system because melee combat system is what builds up all the damage that then gets applied in the damage system. So there is some dependence on which order systems run, and I want to make sure that everything is good there. And I want to just make sure like we're drawing everything in the optimal order. So I'm going to just check on a couple things between sessions. That's about it though. And again, as for this, range scrolls and targeting next time, maybe saving and loading. Delving deeper, I think, was also... delving deeper is not bad. So we could probably do delving deeper, and yeah, delving deeper difficulty, that's easy. then equipment. So probably like 3 more sessions of this before we start getting to some of the other. I mean, this one's super short. So we'll start getting to some of these other ones, and another super short one with blood stains and particle effects. We could hammer through this in like 2 sessions, maybe even 1. Hunger clock, that's fun. I guess it's another system. Yeah, adding a hunger system. Literally a system, but that's also how you would describe it. This game has a hunger system. Literally. Alrighty, so we got a lot going on. I still like kind of looking ahead. It gives us something to anticipate, but it's still going to be another week and a half, 2 weeks to get to some of that, but something to look forward to. So thank you to anyone who showed up today. I really appreciate it. If you are new, I'd appreciate a follow. It's free. I appreciate those Prime subs earlier, definitely. Good stuff. Unexpected, out of nowhere, like boom, boom. I actually thought that first one was a follow because we had a chat message, and then I just heard the thing and I just assumed it was a follow. I was like, oh wait a minute, we got a double Prime subs. I love it. Out of nowhere, damn. Really appreciated though. If you're watching this on YouTube, you know, all the fun YouTube stuff, like button, subscribe, bell, you know how it all works. Leave me a comment. And in any case, you know, feedback is welcome. I know it's not necessarily my code, but just in terms of my presentation, you know, how I do things, are my tangents helpful or not, or like anything, really appreciate it. I want to make sure these are as helpful as possible and all that good stuff, right? I mean, I kind of say it's the end of every session, so I don't think I need to hammer it in too much more at this point. But I do always want to make it clear, like, I think, you know, everybody, if you're watching something like this, you know, hopefully you're getting something out of it. If you're like looking this up on YouTube, you're doing it to learn something, and I'm doing this to learn. We're all trying to learn. We're all trying to get something good here. So if, you know, we can all make sure that the product here, the video, etc., is as good as it can be, that'd be helpful. Alrighty, I guess that's it. So until next time, Monday, we will do range, scrolls, and targeting. And until then, have a good day, have a good night, whatever it is, wherever you're at. Take it easy.
Hail to the king, baby.